Good evening. Today we will explain our lab 2 about operational amplifier using LT-Spice. So there are total 5 configuration in this lab. The first one is inverting amplifier, the second one is non-inverting amplifier, the third one is integrator, the fourth one is differentiator, and the last one is summing amplifier.
My name is Kubendran Analaki N. Nagaraja and my number card matrix is 251091546.
My name is Joshua Nandan Analaki Munendi and my matrix number is 251091543. So there are total 3 objectives to be achieved in this lab. The first one is to understand the basic characteristic of operational amplifier. The second one is to compare theoretical and experimental simulation values. And the third one is to determine the effect of capacitor and the bypass resistor. An inverting amplifier is an operational amplifier circuit where the input signal is fed through the resistor into the inverting terminal and the non-inverting terminal. So this is the circuit and the waveform of the inverting amplifier. Now we will go into the simulation.
So this is the first part, the inverting amplifier. So we can see that the supply is connected to the inverting input of the LM741 operational amplifier while the grounding is connected to the non-inverting input. So the supply settings is in sine wave with the amplitude of 1 voltage peak and frequency 1 kilohertz. So the simulation time is 0.006 seconds. So let's simulate. So the above plot pane is for the input voltage, and while the below plot is used for the output voltage. So we can see that the input voltage is 1 volt sine wave, and the output voltage is also a sine wave, but the voltage is clipped at 14 volts because the output reading is higher than the rated voltage of the operational amplifier, that is 15 volts. So it clips at the point to avoid any damage to the operational amplifier to make sure it operates without any error.
One is non-inverting amplifier. A non-inverting amplifier is an operational amplifier circuit where the input signal is connected to the non-inverting terminal and the inverting terminal is used for the feedback. So this is the circuit and the waveform of the non-inverting amplifier. Now we will go into the simulation.
So the second part is non-inverting amplifier. So we can see that the supply voltage is connected to the non-inverting input while the grounding is connected to the inverting input. So the settings is in sine wave with 1 voltage peak and 1 kilohertz for the frequency, and the stop time is 0.006 seconds. So let's simulate. The above plane is used for the voltage while the below is used for the output voltage. So we can see that the input voltage is in sine wave with 1 volt reading, while the output voltage is also a sine wave with a reading of 11 volts. 11 volts. So the measured value and the calculated value are same according to the lab sheet.
The third one is integrated amplifier. The integrated amplifier converts a signal into its area over time. It turns a square wave into a triangle wave and a pulse into a sloping line. So this is the circuit and the waveform of the integrated amplifier. Now we will go into the simulation.
Simulation for the integrator. So we can see that the positive supply is connected to the inverting side of the input while the grounding is connected to the non-inverting side of the input. So the source is in sine wave with the settings of 1 Vp. So the simulation time is 1 second. So we will run the circuit now. So we will take the last 2 cycles to obtain the actual value. So we can see that the input is in sine wave with 1 volt and the output voltage is in triangular wave with 3.6 volt.
The fourth one is differentiator amplifier. The ideal differentiator amplifier is an inverting amplifier that has a capacitor in the input part, a resistor at the feedback loop. The Vout is proportionally to the negative rate of change of the VE. And this is the example of the circuit in LT-Sprite we had drawn, and this is the waveform which we will be getting in the simulation. Now let us go for the simulation and the demonstration of the circuit.
Explain about the differential amplifier. This is the circuit diagram, and the settings should be same as shown as in the video. And now I'm going to simulate and show us the V in and V out output. And a plot below. And now I'm going to show you the waveform for V in, which is triangular waveform, and V out, which is a square wave. The the charging current is 5 volts and the discharging current is 4 volts. The difference is 1. So the calculated value is 1 volt. So the experiment is also shown as 1.
Last but not least is the summing amplifier. The summing amplifier has two or more inputs. Using concept of Z in and infinity and virtual ground, the V is equals to 0 and has no current through it. The current of I1, I2, I3 combine and form the total current IF which go through R1. And this is the example of the circuit which we have created in LT-Spice, and the waveform should be look like this. And now let us go to the demonstration of summing amplifier.
Show you the circuit of summing amplifier. This is the circuit of summing amplifier, and the setting should be same as shown. DC offset is 0, amplitude 1, and frequency is 300. Now we are going to find out the waveform for V in and V out, and I'm going to simulate the circuit. We add a plot below. Now this is the waveform for V in, and this is the waveform for V out. Both should be the same as a wavy waveform, and the calculated value is 6 volts of V out, and the experimental value is shown as the same as 6 volt. So both are tallied.
As the conclusion of the experiment, at the end of this experiment, me and my lab buddy learned the basic operation of the 5 different operational amplifiers that name inverting, non-inverting, integrator, differentiator, and summoning. We connected the circuit and mentioned in the lab sheet and created the power supply to the positive and negative terminal of the operational amplifier. We achieved the second objective by comparing the theoretical values and the calculated or measured values in the discussion of the experiment. We also identified the effects of the capacitor and the bypass resistor that connected in the integrator circuit and the differentiator circuit along to the amplifier offset and the output voltage. That's all from us today. Thank you.